Hello everyone, today I want to make a short and quick video on how to build this professional race drone. This is a race drone that can take up to 4 or 6S batteries. It's made out of the CherryCraft stamina frame. I got a couple of 3D printed parts that I made myself or that I found on the internet, which I will provide. The technology will not limit yourself here to win races, it will be your racing skills and your flying skills that will be the limiting factor here. Actually, for this drone I was inspired by one of the best racers in Belgium, also a Belgian champion. I've put together this drone in such a way that during normal crashes all elements are maximally protected. I mean the camera and the antenna. Previously I had antenna sticking out a little bit further, which resulted in the antenna always being vulnerable during crash. With this drone the camera can never be hit in a normal crash, and also the antenna can never be hit, and the shark fin is preventing the antenna from hitting the ground. The only thing that can still happen and you cannot prevent, if you crash straight on into a pole like this, you will hit the camera, but there's not much you can do about that in this drone. I highly recommend that you use 3D printed parts for your camera mounts and your antenna mounts, but if you do not have access to a 3D printer, the CherryCraft stamina frame also comes with these standoffs where you can put your micro camera in between. The Foxeer camera also comes with this camera holder, but it is not very easy usable on this frame. For the propellers I've decided to go with the Gemfan Hurricanes 51466. I've seen last year several very experienced pilots use these propellers on this drone and on other drone, and I've tested them out and they fly amazing. They're not cheap, so here I invested a little bit more than I would usually invest on propellers. For flying this drone I have selected one of these two TATTU batteries, so either a 1300 mAh or a little bit smaller one, 1050 mAh with a very high C rating. These are 6S batteries, but you can also choose 4S batteries to fly with this drone. And we're gonna build this frame, so with the CherryCraft stamina, with a very good and decent AIKON stack that comes with an ESC, 4-in-1 ESC and a flight controller on a very small footprint. The Foxeer Aero Micro Pro FPV camera. For this frame it's a good idea to go with a micro size camera because it will fit perfectly in the frame. And for the motors I'm using the XING-E, so economy style motors of 2207 1800 kV, so rated for 6S. This is not a budget drone, but it's somewhere in the middle of an expensive drone and a budget drone because I'm using some very nice parts, which is the flight stack, the ESC and the flight controller. The camera is somewhere in between, the motors are somewhere in between, but very nice quality. The frame is a €50 frame, 5mm thick, so that's a little bit more expensive, but not, let's say, a frame of 80 or 90 euros. And we're gonna use this generic stubby antenna, which is relatively cheap on Banggood, and I'm gonna invest a little bit in a nicely priced Tramp HV video transmitter. And we're gonna use also the FrSKY XM receiver, which is a very small receiver. The AIKON stack comes with a bunch of rubber grommets. You have the smaller ones and you have the bigger ones. So the smaller ones go here and the bigger ones go there. So that's the first thing to do. And voila. In my experience, I found it the most easy to immediately put the full stack onto the frame. You need to take this plate off. The CherryCraft frame has got holes for both 2cm stacks as well as 30mm or 3cm stacks. This is a smaller stack, so we can use the smaller holes. First I put the small standoffs. There are two standoffs, a bigger one and a smaller one, so I use the smaller one on the first layer. This is the back with this extension here. So what I do is this was where the battery will be connected. Voilà, these go in here, and then I like to put the stack immediately in the correct place before I start soldering. So put the cable like this and then turn back like this. Before you put the flight controller on top of the ESC, you should not forget to add the bigger standoffs and then put everything on top. We'll fasten this with these bolts and then we'll start soldering everything. Don't over tighten these bolts, as you will see that the plastic will squeeze out. And it's also a good time to check now that you've equally tightened every lug nut around the same place, so this is horizontal towards each other. This sort of looks okay. Also be sure that the small arrow is pointing forward. This is the back of the drone with the power supply come here, and the arrow should point forward. For this drone with this tech, I prefer to fully tighten the bolts before I start soldering anything. That made my life a little bit easier, and also you have to tighten these bolts very well before you put it here back on the frame, because once it's on the frame you cannot reach these screws anymore to tighten these bolts. So you have to do this in advance, and I prefer to do it now. I'll start soldering the motors onto the board now. Also with the CherryCraft stamina frame you will notice that the sides are not equal. So on the back side there is no cutout, while on the other side there is a cutout for if any motor screw is sticking out, which is not necessarily the case, but the idea is to have this on top where the motor comes, like this. The screws that come with these motors are the perfect length for this 5mm frame. So if you put a screw through, it sticks out just well enough, I think around 2 or 3 millimeters, which is perfect for these motors and this frame. Also get some Loctite or some thread locker somewhere and put a small dip on the screw before you connect it to the motor. This will greatly reduce your screws from coming loose. So now we've got all our motors connected on the frame. The stack is connected fixed, so now it's time to cut these to length and solder them directly on the ESC. For the ESC I like to put the solder iron a little bit hotter to, let's say, around 380, 390 degrees. So that's a quick in and out. We want a nice shiny connection, and we want to have enough on there, like this. When soldering the battery leads on the ESC, be careful not to close these two holes where the capacitor can easily fit in. This the stack comes with two capacitors, a bigger one and a smaller one. This is a 25 volt 330 microfarad capacitor, and this is the same but 35 volt 330 microfarad capacitor. So this is the bigger one. This is for 6S, and if you want to go 3S or 4S you can use a smaller one. In any case I'm using the bigger one. So my capacitor is now soldered in on the ESC. Be sure to put the minus on this side and the plus on this side as indicated on the board here on the ESC. I'll first measure and cut the first cable to length, after which I will make the other cables just one step longer, like this. Always solder both ends of your connection, so the pad on the ESC and also the tip of your cable. Now we can solder it on to the board. Put the first one on a very angled, in a very angled position, like this. And then the next one on a slightly different angle, so they don't touch each other easily. And then the third one I put almost straight onto the pad. Let's say almost 90 degrees from the first cable I did. like this. So the motors are all soldered up to the ESC and ready to go. Now I will decide which solder pads on top I will use and quickly pre-solder them in order to connect the cables. So I'll use the 4 pads of the camera. We'll use them all, including the camera controller. I'm going to use the 4 pads of the VTX, including the soft serial for controlling the VTX settings. Then here you can decide if you want the camera plus to be 5 volt or battery voltage. And the same here. I'm going for battery voltage for both my camera and my VTX, so I will put solder here and here, giving the battery connection through the plus here. And the same here, I'll put solder here, connecting this pad here. I'm going to use a simple XM Plus receiver, and I'm only going to use ground, 5 volt and UART1 receiver pad. So let's solder that up right now. So that's done, the receiver here, and the camera and the VTX will come here. Well, there are several places you can put a small XM FrSKY receiver. I've decided to connect the cables close to the attachments here and actually put the receiver somewhere here, putting it later together here too with some tape, so it sits here in the middle. So I've cut out 3 cables from a bunch of spare cables that I have lying around in the correct color, so black for ground, red for 5 volt, and the signal wire is the yellow wire. Now it's a good time to start testing some things before continuing. What I'd like to do before I connect the battery and to see if I can bind the receiver to my transmitter is to do a shortage test to see if there are no obvious short circuits built in. So connectors that are just next to each other that might connect, that should not happen. The only thing that should connect are the minus leads. They will connect everywhere. But for the rest, everything should be disconnected. Time to solder on the battery lead. The plus goes to the plus side and the minus goes on the minus side. At this point I will remove the 2 standoffs here in the back, because otherwise it's difficult to get to them with your soldering iron. And I'll also put my soldering iron on a high temperature, so 380, to have a quick in and out on these big pads. 3, 2, 1. And now that the battery lead is connected, it's a good time to connect up the stack for the first time with the smoke stopper. So if there is a short, the light will die and not your quad, at least that's the idea. So first test, let's see if there is any smoke. Alright, that seems to be good news. Let's now bind this guy. So already I have a 6S drone configured here. You can bind multiple receivers to one setting on your FrSKY transmitter. So I will bind an additional drone to this model. So let's just go to the bind settings, enable the bind mode. Here I'm selecting 1 to 8 channel telemetry off. Now it goes into bind. And now we need to power on the receiver while holding this small button here. So let's press the button, see if I can do it with one hand. That seems to be good. Now let's terminate the bind mode and go back and repower. Goes from red into green, so we have a proper binding and we should be able to arm the motors.
Engines armed.
But that's not yet configured. So time to connect it to Betaflight. So I've downloaded the latest Betaflight 10.6.0 and I've selected the AIKON F4 Legacy 4.0.6 firmware. I've loaded the firmware online and now I'm flashing firmware successful. So now is a good time to verify if our receiver is working well. So yaw is working, throttle is working, everything nice from 1000 to 2000, so that's well configured. Roll is from 1000 to 2000 and the pitch. Here is my RSSI value on channel 12. So you don't have to configure telemetry while binding your receiver, but you get it on channel 12. Then here my arm channel,
launch mode, horizon mode,
flight mode channel, beeper and flip control, and something to change my tree profile ratings. So this is how I like to configure my buttons on the FrSKY XLite Pro receiver. I'll put the arm here on this button.
Engines armed. Engine disabled.
Here I put
Launch mode.
my different
Horizon.
flight modes.
Launch mode. Race mode.
Here I've got the beeper and the flip over button. So you see beeper and flip on crash is enabled at the same time. And here nothing happens, but I use this button to switch my profile rates. So if you actually see, if I use this button, then I can switch 3 positions. And this I use to select either rate profile 1, 2 or 3. That's how I like to do my setup. Don't know exactly how this works, but even without a beeper installed, this drone makes quite a noise via the motors. I don't have the correct shrinking tape with me, so I just use some electrical tape to protect the receiver from the other electronics. So like this. And now we'll put it here with a small piece of double-sided tape. Now it's time to put in the Foxeer Micro Aero Pro camera. The camera comes with this cable. One side fits into the camera while the other side is a little bit bigger and does not fit inside of the camera. I'm not sure how this can work, but we only need a small part of this cable, the one that goes in here, and we don't need all the cables, so I'll show you how I do it. So we only need this end of the cable where the joystick to configure the camera is supposed to connect to, and we only need a very small piece of it because the camera will come here and sit here. So we'll cut this off here, and also the connections are perfectly positioned here on this side of the board. Cut away this part here. Then this is a double ground. We won't be using the joystick because Betaflight can simulate the joystick for us, so we don't need the double ground. So we can move one of them over here. But we do need the joystick cable, so we'll also make that the same length over here. And then we have a voltage sensing wire that I'm actually not using, so I'm also gonna cut that off at the base. So here you go. This one we will connect on the board. This is actually how the setup should be done on the flight controller. The camera controller is here. Then you've got the yellow video in. Then we've got the positive, and then we've got the ground. Don't throw away this cable. We will not use it, but it will come in very handy in other projects. These small cables I usually strip with a very sharp knife. We only need a very small tip. So let's solder these ends and solder them on the flight controller. And that's how that then looks. I've printed this camera holder that will go in front of here. That will be the perfect fit for holding this camera. This is printed in a flex material, which means it will bend like a rubber. This is really the best material for your camera holders and for your antenna holder because it's bendable and you can firmly put stuff in there without breaking anything. The shark fin is not printed in flex. This one is printed in PET or PET-G because this needs to be stiff and be used outside. You can also print this in PLA, but it's not so strong, or in ABS. Put the screws in here, and this is the best way I found. It's the most cheap and most lightweight way and convenient way of fixing a camera onto your frame. So this goes here. We'll do that later on. The Tramp video transmitter comes with several cables. You have actually 3 cable possibilities for this connector. I'm not going to use the NFC configurator, as it is yet another thing to manage and to put in this very small frame. It is just too big to put in there. You can use any of these cables. I'm going to use these ones. We don't need all the cables. We don't need the audio. We will use the telemetry, the video signal obviously. The 5 volt is a 5 volt out, which we're not going to use. We're going to put the ground here and we're going to put the battery voltage here. So this one we can snip off, and also the orange one we can snip off. The Tramp requires as input 2 to 6S LiPo, so you cannot use any 5 volt supply from the flight controller, because you actually need 2S, which is around 7 to 8 volt, let's say. So I have my wires stripped and pre-soldered, and this is actually how they will be put on the board. So ground, positive battery voltage, the video signal and the soft serial signal for configuring the Tramp via the flight controller. And there you go, we've got our camera lead and our VTX lead all together, and the VTX will be positioned like this on top here. So now it's time to start putting things together. I've put a small piece of double-sided tape on the receiver, and I'm actually going to position it here so it sticks. The camera is already inserted in the 3D printed holder, and we can now easily put it over the frame holders. And because it's flexible and it's a little bit smaller, it fits really well and really snug. Now I'll connect this cable onto here. So I've pushed the camera holder frame as low as possible, so that it's just not connecting here, and that we have some space here, because I will actually put the Tramp transmitter, I'll put it somewhere like here. Now it's time to start tidying up a few things. So the cables here, I will put them in place with a small piece of electrical tape, like this, and also put one over here. So when it's all cleaned up with some tape, this is how it looks like, a really nice and clean cable design. Time for the antenna mount. So the stubby antenna fits really snug. You really have to push it in there like this. Voila. And this is how the drone looks almost complete. The top plate will be here, and I will now detach the double-sided tape and connect it to the top plate. So here's the almost final product, and I managed to be capable of putting the shark fin in the wrong direction. Bravo! In order to securely attach the battery to the drone, I do a couple of things. First of all, I work with a rubber that keeps the balance lead nicely attached to the battery, so it's not swinging around and ending up inside of propeller spinning around. I leave the battery lead coming from the ESC quite long, because this allows me to properly align the cables like this, so the drone can fit flat on any surface like this. Additionally, because this is still moving quite a lot, in order to prevent the battery from shifting out, I also use two Velcro strips. One goes on the battery and one goes on the bottom of the drone, to prevent the battery from easily sliding out. So with the Velcros attached to the drone and to the battery, you have a very good fit once you add the battery strap, and your battery will always stay in place very well. The technology will not limit yourself here to win races. It will be your racing skills and your flying skills that will be the limiting factor here.